Hello, welcome back. So it's the week 2, part 3. Rather like the second part of the part 2. So last time, in the REST BOD, I talked about that we are going to cover more about the UML notations. What we are going to focus on, because that there are so many UML notations, right? If you imagine that the construction schematics, there are so many different types of the construction schematics that you really can't run all of them in 1 week. So same thing happens in the software development. And what we are going to focus on in this particular week, is the class diagram. And that's what we are going to cover this week. And we have been covering so far a little bit, and we are going to do more. Okay, so this is the class diagram. Just a short recap. So UML notation, what we are focusing on is the class diagram. So this is a very simple class diagram. I already talked about the abstract class, which has an abstract methods. These abstract classes must be inherited, but must be overridden. Must be overridden, right? Now you remember. Override it to get rid of the abstract part of the methods, right? And this is called abstract class, and this is just a regular class. And we all know this named instance. We have a variable named Park, and it is a realized instance of class customer. And sometimes we use objects which are not really assigned to a certain variable, but it's there sometimes, and that is called unnamed instance, like this, right? And again, it's just a short recap. And instance name is here, and class name is here, right? Park and customer. And this is the first box. It specifies the name and the instance name of the class. And in the second box, what we have is the data member variables. In MATLAB world is called properties, right? And we have ID, account number, and name. We have a certain types here, and this specifies the default value. Okay? And in the third box, here is the third box, these are the methods, functions, collection of functions, right? And we have login function, request withdrawal function, and confirm security card function. Okay? So this is the 1, 2, 3 boxes here, consists of a single class diagram, and the first box says the name of the class, and the second box says what it's going to store, and so the third box of the class diagram specifies the behavior of the functions, operations of the class. Okay, so we already covered this in the last part. Okay, if we talked about the schematics, right? Mostly in the context of the construction field. How about the software development? What's the real world schematics for the software development, like the class diagram looks like? This is a simple example of the class diagram. You see that there are many classes. And not just a collection of classes, they are interlinked, right? Interlinked. Link means that we have a certain relationships between classes. We already covered one particular relationships between the classes, where it's actually here, generalization. This is the hollow point arrow. How it looks like this. Okay, so it's the generalization. Means that credit, cash, check are the subclasses right? And this is the superclass, right? Very interesting. Having said that, we have these association relationships here, right? And we have multiplicity here, right? And we have a certain, it's called aggregation. It's not here. Aggregation relationships here, right? Or interesting, we have been covered so far. We know this abstract class, what it means, right? It means that we have some classes that are not, that are defined by the signatures, but its substance are not defined yet, right? The payment is the abstract class. It means that it should have the subclasses inheriting the payment, and these three classes are those. Okay. So in the next a kind of 10 of the slides are going to cover what's this, right? The association relationship, this aggregation relationships, and the multiplicity means, and the navigability means, and etc. Okay. So that later, what you really can do is that when you see this UML notation in the class diagrams, then you can just turn this class diagram into programming codes, MATLAB codes. That's what we are aiming to, right? Aiming at. And in the offline course, what I'm going to do is that I'm going to show you a unorganized, really MATLAB codes, and we'll ask you to organize by showing you a class diagram. And what you are going to do is that you are going to organize it according to the given class diagram. So it's very important for you to learn how to read and how to implement the class diagram design. Okay. So we already know this generalization, right? We have person, this is the super, and these are the sub, and these are the instances, right? These are the instances. So it's called base class, right? And it's called Ric class. Okay? We already know this.